Cracking open the surgeon's toolbox to talk about something pretty incredible: skin grafting. This procedure is amazing. It's been saving lives and restoring bodies for ages. We're going to get into how surgeons can literally borrow skin to heal wounds that might seem unhealable.
So let's just start with the basic problem, right? Imagine a really bad burn or a deep wound where a big patch of skin is just gone. Our bodies are fantastic at healing for sure, but sometimes the damage is just too much. So what happens when the body's own repair crew can't close that gap?
Well, the most elegant solution is also, believe it or not, the simplest one. You just borrow from yourself. And that's the whole idea behind what's called autologous grafting. It's really the gold standard in skin transplants.
Okay, so what does that actually mean? It means a surgeon takes a patch of your own healthy skin from somewhere else, say your thigh, and moves it over to the wound. And here's the beautiful part. Because it's your tissue, your body recognizes it. There's no alarm bell, no foreign invader to fight off. This cuts the risk of rejection way, way down and just sets everything up for a successful heal.
Now, to be clear, using your own skin and autograft isn't the only option out there. You've got allografts, which come from another person, and even xenografts, which can come from animals like pigs. But really, you should think of those as temporary fixes, like a biological Band-Aid. For a permanent, seamless repair, the autograft, your own skin, is the absolute champion. And that's what we're going to dig into today.
But even when we're talking about using your own skin, it's not a one-size-fits-all deal. Surgeons have two main tools in their kit, and picking the right one boils down to this really critical trade-off. What's more important here, covering a massive area or getting a flawless cosmetic result?
So first up, you have the split-thickness skin graft, or STSG for short. With this one, the surgeon just shaves off the very top layers of skin. It's kind of like peeling a potato very, very thinly. This is the go-to for covering big wounds, like a major burn across someone's back. On the other hand, you have the full-thickness skin graft, or FTSG. This is the whole shebang, both the top layer and the deep layer of skin. And you save this one for really visible spots, like on the face, where you absolutely need the best cosmetic match possible.
And this is where those trade-offs really come into play. Let's look at the STSG again. It's a total workhorse. The spot they take it from heals up pretty easily, almost like a scraped knee, and the graft itself is really likely to succeed. The big downside? Aesthetics. It can look a bit like a patch, and sometimes it shrinks or scars weirdly. Now the FTSG, it gives you this beautiful, natural look with way less shrinking, but it's a lot more demanding. The donor site needs to be stitched closed, and the patient has to keep that new graft totally immobilized for it to work.
And hey, this isn't just some textbook theory. A pretty recent study from 2024 published in Microsurgery backed all this up with hard data. When it comes to pure aesthetics, yeah, full-thickness grafts are the undeniable winner. They give you way better cosmetic results, and importantly, don't mess with how the area functions.
Okay, so how do they actually do this? I mean, what does it look like? Let's step inside the OR, metaphorically of course, and walk through how these grafts are harvested, step by step.
All right, for a split-thickness graft, it's all about precision. First, they lubricate the donor site. Then the surgeon grabs this tool called a powered dermatome. Honestly, the best way to picture it is like a high-tech, super precise electric razor. They set it to the exact thickness they need. We're talking fractions of an inch here. Then, with this really steady, smooth motion, almost like an airplane taking off, the dermatome just glides over the skin and shaves off this perfect, thin sheet.
Taking a full-thickness graft, though, feels a lot more like a classic surgery. The surgeon uses a scalpel and carefully cuts out a whole piece of skin, usually in an oval shape. Then comes this absolutely critical part. With scissors, they painstakingly trim away all the underlying fat. And this is so important. Why? Because fat has a terrible blood supply. For the graft to live, that deep layer of skin needs to make direct contact with the wound bed, which is full of blood vessels. After that's done, they just stitch the donor site closed.
And this graphic here is awesome. It shows us what the recipient site looks like. This particular one is for a graft inside the mouth. But you know what? The principle is always the same, no matter where it is on the body. The surgeon has to prepare this fresh, raw, bloody surface. That's the fertile ground for the new skin. Then, the graft we just saw them harvest gets laid on top and stitched into place. This gives it the absolute best shot at connecting and thriving.
Oh, but wait, before they finish stitching it all up, surgeons have this super clever trick up their sleeve. It's called pie crusting. And no, it's not for decoration. They make a bunch of tiny little slits in the graft itself. This creates a drainage system. It lets any blood or fluid escape instead of pooling underneath, because if that fluid builds up, it could literally push the graft away from its new home and cause the whole thing to fail. It's such a simple little step, but it makes a huge difference in the success rate.
Okay, so the graft is stitched down, job done, right? Not even close. The surgery is really only half the battle. Now the real magic has to happen. This is the biological process of the graft taking, actually becoming a living, breathing part of the patient's body.
This whole healing process happens in 3 main stages. For the first 48 hours or so, the graft is basically just surviving. It's a process called plasmatic imbibition, which is just a fancy way of saying it's soaking up nutrients from the wound bed like a little sponge. After that comes inosculation. Think of this as a kind of kiss, where the tiny blood vessels from the wound start to connect with the vessels that are already in the graft. And finally, you get capillary ingrowth. That's when new blood vessels actively grow into the graft, reestablishing circulation and creating a permanent lifeline.
I mean, this whole thing is a total medical marvel, right? But it does have one big limitation. What do you do when a patient, like someone with massive burns, just doesn't have enough healthy skin left to donate? Well, that's where the future of all this is heading. Engineering brand new skin, basically from scratch.
So say hello to bioengineered skin grafts. This is the next frontier. Basically, scientists create this biocompatible scaffold. You can picture it like a biological lattice or a piece of netting. Then they seed it with the patient's own cells that have been grown in a lab. They add a cocktail of growth factors and other molecules, and what you get is a living, functional skin substitute that can heal a wound without having to create another wound somewhere else on the body.
And get this, the results are, well, they're incredible. There was one study looking at a human skin substitute, HSS, for wounds left after skin cancer surgery. It found that it led to complete healing in 100% of cases. 100%. And not only that, the cosmetic results were actually better than with traditional healing.
Which of course brings us to a really fascinating final question. As we get better and better at literally growing skin in a lab, are we heading towards a future where donor sites are a thing of the past? Imagine that, a future where we don't have to create a new wound to heal an old one. It's a pretty powerful idea to think about.